Thank you. Good morning, everyone. Thank you all for being here this morning. As mentioned, we're in Run 101, Value for IoT in Smart Government Infrastructure session. I just want to reintroduce myself, Ali Hassan. I'm a BD in our worldwide public sector partner organization, and I'm part of the team that helps our partners utilize a lot of AWS IoT solutions and services. So I focus heavily on all sorts of partners, ISVs, consulting, technology. My peer, Chris, you want to introduce yourself?
Yeah, hi everyone. So my name is Chris Hazer. I'm an IoT specialist, solutions architect, and I work with the public sector. I've been doing this for 4 years within AWS, helping build solutions for our partners and our customers in various verticals within the sector. Thanks.
Cool. So today we want to spend a little time, as the title says, smart government infrastructure, right? So we want to spend a little time defining these terms, because government infrastructure can mean a lot of things. So we want to spend a little time explaining that. And then the word smart, which has been overused in the past, we need to sort of define that a little more crisply, what it means to AWS, what we think it means to our customers. And then we need to recognize that this journey to being smart or being data-driven comes with challenges. It's not something you just turn on a light switch and you're data-driven or smart overnight. So we'll recognize some of those challenges. And then the journey obviously has a technology aspect. And that's where Chris will come in and talk through all the different AWS services, IoT, and some of the high-level services that help enable us on this journey. And we're dividing this session into two segments. One is data-driven communities. Communities for us is cities, roadways, I'll talk about some of this, etc. And then we're focusing a little bit on data-driven industries, which are sort of the utilities and manufacturing environments. And then lastly, we'll wrap it up with any next steps. So when you think of government infrastructure, right, the first thing that typically comes to mind is a city. We oversimplify cities to say, hey, a city is a government-managed environment, but we forget there's a lot of components that go into cities. Cities are very complex environments. There is transportation, there is public works, there is waste management, also different aspects of it, right? So city obviously is one of the key infrastructures that needs to be maintained. And so there's a lot of different departments that work together to make this happen. So that's our first infrastructure that we're going to focus on. Moving on, campuses, higher ed, K-12, all sort of look and feel like cities as well. Right? They might not be as big as the tier 1, tier 2 cities, but they're still environments that tend to have their own public utility. In some cases, they have their own police departments, so they operate very similar to cities as well. And then moving on to buildings. Buildings, I think, have become really interesting lately, because when you look at cities and campuses, a lot of the use cases for IoT are outdoor, right? There's parking, there's lighting, there's tolling, there's transportation, etc. When you look at buildings, there's a lot of indoor use cases that we tend to focus on. And especially with the ongoing pandemic, it's become even more important. The questions we're asking is, how safe is this building, right? How secure do I feel walking into this building? How clean is it? How densely populated is it right now? Who else has been at this desk? So these are the kind of things that are driving the value of me being in the building, and what kind of data can I generate from the building to answer some of these questions. And then roadways. Roadways tend to be the artery of our cities, right? They kind of connect all the different aspects together. But when we think of roadways, I feel I sometimes oversimplify it to say, oh, highways and streets. But we forget there's a lot of assets that connect to those roadways, right? Like I mentioned, there's toll booths, there's lighting infrastructure, there's parking that goes with it, there's just public Wi-Fi, there's fiber connectivity, broadband that connects with a lot of Department of Transportation have to deal with. So roadways are critical infrastructure, and as we're seeing right now, all over the US and other parts as well, they're in dire need of attention. Right? We haven't done a great job keeping up with some of our roadways, and we definitely need to figure out how to improve that and how does technology help improve that. So moving on to the same theme, right? I mean, you kind of get the idea. There's airports, bases, they're all communities or environments that are having the same challenges. They're all still moving people around, moving cars. They're creating these communities where you can interact with each other and where data plays an important role. Federal bases, for example, are a good example. They, again, look and feel like cities. In some cases, they are as big as some of our smaller cities. and they have their own siloed departments that work together. So all of these, the cities, the campuses, the bases, airports, we're going to couple all of these together, and we're calling them smart communities or data-driven communities. Right? They kind of fall in one bucket. And then we move to industries and utilities. These look and feel a little different because while the communities are dealing with people and the challenges that people run into and bring the community together, industries have some of that, but they have a heavy presence of machine and equipment. And some of the top use cases over there are how efficient is my production process, right? How can I optimize it better? Are my machines operating at the best level? Can I predict any failures that are going to come? So these kind of fall into a slightly different bucket that we're calling data-driven or smart industries. So hopefully that provides a bit of a clear picture on what we mean by government infrastructures. And then let's move on to this word smart. Like I mentioned earlier, it's been used heavily. It's been defined very loosely across the board. Everyone has their own definition of smart, and some are right, some are a little off. So we define smart as through 5 basic components, right? The first is for any city, project, initiative to be smart, we feel there has to be a hardware layer at the edge. And that's what the IoT portion comes in. There needs to be some sensors, some gateway, something that provides connectivity to a device, machine, asset. So that's the key here. The second is that device just being connected and the hardware just sitting there doesn't provide any value unless you have a software layer sitting on that that is able to extract that data out. And then also software can be spread throughout the stack. It's not just at the edge of the microprocessors. We have gateways at the edge. We have software infrastructure in the cloud. All of that needs to be able to talk to each other and provide value in extracting that data, connecting it, and sharing it up. The third most important thing is connectivity, right? Unless these devices are connected through whatever network, you have cellular, you have Wi-Fi, you have fiber, broadband, they don't provide a lot of value. So connectivity through our cellular providers becomes critically important. But one important thing over here is it's not just being important about being connected. Also, what do you do when you're not connected? Right? In a lot of environments, connectivity is scarce or connectivity can go down. So how does my system operate when it's not connected back to the infrastructure? So it needs to be able to provide some sort of localized decision making, some sort of edge computing for it to be smart. So we have to look at both angles of connectivity. And then once we have connected devices, brought the sensors in a central location, now they have the data, great. It looks great. It's a bunch of ones and zeros. That means nothing to me, unless I provide some sort of analysis on that, right? And analysis is typically done on real-time data or historical data. But analysis is the idea of just getting some sort of value from that data, right? Analyzing it to get patterns, behaviors, and understand, all right, this is what it means. So that's critical for any infrastructure, anything to be smart. And then lastly, while data analysis looks at the current and historical data, AI, ML, machine learning, artificial intelligence is a little forward-looking, right? Once we've derived the patterns from the data analysis, now we say, hey, how do we apply this to models, and how do we predict how the data is going to behave, or how the asset's going to behave? So that's where predictive maintenance comes into play. And we're trying to say, can we predict when things are going to fail? Can we predict certain type of behaviors? So all of these together, we feel, for us, define what smart means. And this could apply to any of the communities I mentioned, industries, or just individual projects. So why do we need to be smart? Right? Why do we need to be data-driven? I mean, things seem to be working fine. We feel there's an abundance of sensors that are already here and coming, right? Whether we like it or not, predictions are 75 billion connected devices, all the way from our home to commercial environments, to cities, to roadways, etc. So data is going to be home. There's no question about it, right? So we need to figure out how to leverage this data. We need to figure out how to apply this data, and we need to have a plan, right? It's not something we can do reactively. It's important to be proactive and have some sort of a plan. So that's why with this growth of devices, it's important to start strategizing. But this growth of devices also brings a ton of challenges with it, right? First, like I mentioned, the sheer scale and size of data, the volume, is not something our old systems were built to handle. Right? All the on-premise environments, they weren't designed to build that volume of data. So it's really important to understand, what do I do with this data? Where does it need to sit? Do I need to migrate it? Where does it need to migrate? And wherever I do migrate it, can it handle this scale? Secondly, data is coming from different sources because of IoT. It looks different, it feels different, And right now, for a lot of government agencies, it's sitting in different silos. There's a lot of data sets and data lakes environments sitting separately. While that works, it's not really providing a lot of value because the data is not talking to each other. So it's important to figure out how do we break through these silos and apply some of the technology across the group. The third is machine learning sounds exciting, and it is. There's a lot of cool use cases throughout the sessions you might have heard, but there's still a lot of there's a skill gap, right? A lot of agencies, customers still don't have the comfort or there's organizational inertia against machine learning to say, hey, we have the data, we just don't know how to apply it, or we're not skilled enough in machine learning. So there's a skill gap that I think needs to be addressed as well. It's not just technology. And then lastly, security, right? I mean, data sitting in silos or sitting in one repository, it's important for it to be secure, it's important for it to be autonomous, and it's important for it to be in compliance. If we're dealing with federal regulations and stuff, we need to address all these challenges. So it's not something we can just do, right? We have to recognize there are challenges in the journey. The good thing is AWS has a lot of services. The breadth and depth of our services and the programs we provide to our partners and our customers can help address some of these through these steps. Right? The first step is, we feel, migration. Take a simple workload, an IoT project, an IoT workload, existing or new, and migrating it to the cloud helps free up IT resources. Right? There's a lot of offset you can do to the cloud that helps you free up those resources that you can apply elsewhere. Once you've migrated to the cloud, the AWS cloud provides a lot of the compliances and security that's required to address some of these challenges. Right? So it's all built in. And then I'm sure you've heard of the shared responsibility model where the security of the cloud itself is on AWS, the security in the cloud of the application lies on our customers, but that's where we partner together and help you get all the compliances and security levels you need. The third thing is, once you have your applications in the cloud, how do you modernize them? How do you apply some of the latest technologies with serverless and Lambda and modernize your application from a monolithic environment to a new environment and prepare it for scale? So I talked about the scalability of data. AWS Cloud provides a lot of that value and the ability to scale that data. And then I won't go through all of these, but we have a ton of training services to help apply to machine learning. We have a lot of skills that people can take workshops and get trained on. So from edge to outcome, we can provide all the services and the training needed to start this journey. I like this quote because I mentioned smart, I mentioned this journey, I mentioned, in 5 slides I kind of summarize how you can become super smart and apply intelligent data. But the fact is, it's not easy. It's definitely a journey. But I think what's important is, A, have a bold vision. Right? We need to have a bold vision of where we want our community going. Right? How do we make it smart? But then we need to have incremental initiatives and wins in the middle. So the journey needs to be as good as the initiatives in the middle. So it's important to have projects. You start small and then have quick wins, have ROI that shows, hey, this is actually working, and it lines up with our overall vision. So this is why I really want to apply this goal. And there's a journey we have to take, but there's a journey also the data itself has to take. So I'm going to hand it off to Chris now to talk about the journey the data is going to take through this.
Thanks, Alan. Okay, so yeah, let's walk through the journey that this data will take. And so really, ultimately, when we talk about smart infrastructure and getting this data off your devices and your assets, the goal really is to drive positive outcomes. And this can be for your communities, your government, and organizations. And so to do this, you need a robust set of services. So first, when we work with the edge, we need to securely connect these devices and process and transmit this data, whether it's from industrial machines or all kinds of assets you may have within your communities. An example could be HVAC systems, security systems, manufacturing equipment, public utilities, vehicle fleets, and many more. And so depending on the use case, we need services to help us control and connect these devices securely. Being able to do that kind of translation with that device layer at the on-premise and it securely transmits to the cloud. And so once this data is in the cloud, this is where you start to store, you analyze, you train machine learning models to create intelligence for your various assets. You're trying to do predictive or prescriptive maintenance on devices. And this really helps you drive these outcomes we talked about, where it could be very broad from case to case. So here's some list of some of these examples of various outcomes you can achieve. We look at faster data-driven decisions, using machine learning to help us automate some of these decisions where possible. If you look at community and safety situations where perhaps you're looking to analyze the density of traffic within a building for cleaning and maintenance purposes. If you think of production and manufacturing, increasing efficiencies in your operations. If I have an asset that makes a product, I measure how well it does based on how often I use it when it's scheduled for use, how fast it can make product based on the product I'm making, right? And whether I'm making good product. I don't want to make 1,000 pieces of a widget and only half of them are good, right? So we have different ways to create measurements on outcomes of your performance of your assets and the safeties and other things, the other use cases described here. However, these outcomes will not be achieved in a one-way street, right? You want to look at this and think of it as a way where this requires a virtuous cycle, where you're capturing a lot of this information and driving intelligence you can drive back to the edge and act on. So it starts with sensing and collecting this data, analyzing the data sets you have, looking at performance of items and assets, training machine learning models to predict when you might see a failure or predict when there is a downtime event or a safety situation. But being able to act on that and notify the right personnel or right people involved in this, in the maintenance or operations of the asset or building. So this leads us to a set of IoT services I want to give you a highlight over at AWS and how this helps us achieve your solutions and drive the data journey to the cloud and back, right, as you create this virtuous cycle. So it starts with 3 different pillars we have for how we categorize our different services. And it starts with the edge. A lot of our customers start with edge and devices. And then we drive management and control of these different edge services and things and gateways using our connectivity and control services. And this is a scalable set of services we have that can really grow with your organization as you onboard and provision as many devices as you have needed for your solutions. And with the data you capture through these services, we then do analytics and AI and ML on the data sets you have captured. And this helps you drive this true value. And with this intelligence you create, this can be deployed back to the edge, creating that virtuous life cycle, ultimately driving outcomes in your organization. So let's go over just a highlight here. There's a lot of services we have. I won't be able to dive in too much in each one, but give you a little overview of some of these services. And it starts with IoT Green Grass. So we have gateways and things. So keep an idea of the separation. Green Grass acts as a gateway where it can drive and deliver a lot of capabilities, whether it's software, intelligence, being able to manage multiple things at the edge offline. So it has a robust set of features that gives you several capabilities. Maybe I want to do object detection with a camera, right? So you can deploy object detection models that have been trained in Sagemaker and execute those on Greengrass. Maybe I have 1,000 IoT devices that I want to connect to an MQTT broker. You can do that, right? You can deploy an MQTT broker to Greengrass and support connectivity from locally from 1,000 or so or many devices you may have on-prem. And as a secured endpoint, this provides that secure transmission of this data to the cloud that's encrypted, right? And so you're going to find when you have many assets within your organization, a lot of ones you've invested over the years, they're using vendor-specific protocols, they're using old legacy protocols for communication. And so Greengrass helps bridge that gap with various sensors and assets or systems using their support protocols. This leads us into Freertos. If you're building devices, your own microcontrollers, your own sensors, we also offer an operating system for real-time operating system called Freertos. This is open source, as well as the Greengrass client is open source at the edge. And with this real-time operating system, we embed several capabilities to make your life easier, like over-the-air updates, right? The library is to connect to Greengrass, so you can have it connect to Greengrass, or you can have this connect directly to the cloud to stream data and provide management. So with RoboMaker on the right, we also provide other services, and we build on top of our own services, right? So RoboMaker is a solution that lets you develop and deploy robot operating system files to your robots, your fleets. And this actually runs and deploys on top of Greengrass. So we use Greengrass in your robot to handle the delivery of those operating system files. And if you're looking to use infrastructure, we provide as well our own infrastructure, but services like Greengrass and the others can run on your own devices. But we also have Snow products, ruggedized hardware, storage gateways, outposts, which are permanently installed racks, and also regions like Wavery. So this moves us towards connectivity and control. Now I need to manage these gateways, I need to manage these devices. It may be easy to do 1 or 2 devices in your development or testing, but as you scale, it's very important that you have a service to help you manage the life cycle of this device or asset or gateway. And so we have services like IoT Core. This is our broker that sits within the cloud. It's a managed service. It can handle millions of devices that you may want to connect to it. And with this, it's a pub-sub broker. You publish data to it. You subscribe to data from it. It also has the ability to support that connectivity from many devices and things. And with this, we support also services or frequencies and protocols like LoRaWAN. So we can support MQTT as a connectivity protocol to push data to IoT Core. But also, if you have LoRa, you can have a LoRa basic gateway on-prem that's pulling data from low-powered sensors, and as well ingest this data through IoT Core. We also give you services to help you manage your devices, like device management, and services to help audit the policies you've created for them to make sure they're secure, and also audit the behavior of those devices to make sure they're not acting abnormally. And that's would be services like Device Defender that helps audit and securely monitor your devices. Now, depending on the data you send, it's not always just messages, right? It could be video. It could be large data sets. It could be log files. It could be, things that you need to handle different protocols for that kind of ingestion. And MQTT as a protocol may not be appropriate for everything. And so that's why we can give you also Kinesis data streams and Kinesis as a service for ways for you to ingest this other kind of data, which is typically would be seen within communities and other types of industries. So this leads us to analytics. Once you capture this data, you have your assets and gateways. Now let's try to drive intelligence or insights from your information. And so we give you services to help you extract this information, do metric calculations, and modeling of your different assets. Services like SiteWise do this. And they give you also a visualization layer on top of it. There's services for extracting and transforming this data like IoT analytics to help make any type of conversions or translations or marry data from multiple systems with your IoT data. And if you're monitoring the behavior of an IoT device or asset, we also have services like Iot Events, which is like a state machine that monitors the state of your device, and you can take multiple actions through the life cycle of that different state change. And with the machine learning on the right, that's where we introduce a whole other set of services where you have storage, your data lakes, the ability to train and do machine learning, build machine learning models with Sagemaker. So we give you a robust set of services to help you create this type of intelligence and training. And what's great with Sagemaker, we have that ability to pull those models you trained through Greengrass and deploy that back to the edge to be executed locally for inference. So what I want to leave you here is with a high-level picture of these services from edge to outcomes. And you get to see where we have those edge services fit on the left, like Freertos, like Greengrass, and our Snow products for infrastructure. And this is managed and data is ingested from these services at the edge in the cloud by services like IoT Core, Kinesis, Sitewise, and other services. Ultimately here, the goal is to help you drive those outcomes and create this virtuous life cycle within your environment.
Cool. Thanks, Chris. Sure. So let's shift gears a little bit. So we heard from all the different services in the IoT, AIML, and additional capabilities. Let's figure out how this applies to data-driven communities or smart communities. But before we do that, I just want to sort of define the opportunity, right? Is there an opportunity over here? And for us, the numbers speak to that, right? So when you look at engineering and construction as an industry, the growth has been tremendously slow, 1% compared to 2.8% or 3% in other verticals, right? So there's tremendous opportunity for growth to take place, innovation to take place in those spaces. And then there's clear spending. IDC reports about $190 billion globally are expected to be spent on smart city initiatives. And if in the US, if the infrastructure bill goes through, we could see this number go further up, at least for North America. And then lastly, the impact, right? Is technology having an impact? So when McKinsey actually did a survey where they identified 63% people believe that digital transformation was achieved by applying technology. Not just improvement, not just an upgrade, this is true transformation where it really impacts the business and changes the way you do business and get value from it. So for those reasons, we're focused on smart city globally, and IDC has actually named AWS as a leader for smart city platforms. And the reason for that, they define as the breadth and depth of services, right? We provide all the services from the edge to the outcome to be able to create a smart city initiative, a platform. Customers are doing this themselves. We have partners that help enable this, ISVs, consulting partners. So we clearly are holding a leadership position in the smart city space as defined by IDC. And then another strategic partnership I wanted to mention in this space is there's an organization called Open and Agile Smart Cities. It's a global community of bringing different cities to connect to each other through open data. And the idea is how comfortable are cities sharing data across with each other safely, securely, so that more value is achieved across the board, right? AWS is a strategic partner with OAS, where we're enabling all the technology components you need to create these data lakes. And also we've created a framework that you see on the left, on the right, built on these open standards. So if you're looking to develop a smart city platform, we have a framework that you could apply based on these technologies and tweak into your own needs. So IoT within smart cities, there's a ton of different use cases we're focusing on. And the way we focus on these use cases is we have vertical teams that are heavily embedded in these use cases. So if you look at transportation, we have transportation leaders, we have a whole team that's focused on tolling, airports, transit authorities, roadways and infrastructure. They're experts in the industry, and they work with our customers, with our partners in that area. Similarly, we have a justice and public safety team that focuses on public safety use cases around surveillance, outdoor, indoor surveillance, criminal justice, prisons, police departments, fire departments. And then we have partners that are doing smart waste management, whether that's checking the status of bins or actual fleet management of all the waste trucks and stuff. So we have solutions in that area. And then power and utilities, where we have a whole different division and leaders that focus in that space and help our customers achieve their outcomes with the domain knowledge that's needed. So a lot of different use cases across the board, and IoT applies to all of this, right? Because all of these require some level of sensor integration, some level of data extraction. So I want to share an example from a customer we work closely with, City of Detroit. They have about 2,500 miles of roadways, I think 800 or so traffic signals, and they have a small IT staff, 50 people that are managing this entire infrastructure. The challenge they kept running into was they had no visibility into these assets because they weren't connected. There was no way they could tell if a traffic light went down, and if they did find out, the time to resolution was about 8 hours. And you can imagine the type of congestion that would create in the city, in the roadways. So they partnered with a partner of ours and applied their solution, which is built on AWS IoT. Maya Vision has a solution called Traffic Link. And what they do is they create these edge connections to these to these intersections that now connect you back to the cloud. And they're leveraging AWS IoT Greengrass to achieve that, and IoT core in the back end. And then obviously the higher level services that go with that. The impact that had was they were now connected their entire infrastructure. They had visibility into every time a light went down or there was traffic or anything like that. And the time to resolution was trimmed down from 8 hours to 2 hours now. So huge impact just by connecting the assets. But now that the assets were connected, you don't need to stop it. They started applying additional capability to say, hey, now that we have a connected intersection, can we attach a camera over there and look at traffic patterns? Can we apply machine learning models to figure out where are we seeing the highest density of traffic? Can we route traffic effectively because now we have more data coming in from the edge devices? So like I mentioned, connectivity is important, but it only provides the first step in that journey to becoming smart. Right now you can apply additional high-level capabilities just by getting that device connected to IoT. So another customer I want to highlight, and we're going to have a video from them, is Carrier. Carrier is hopefully a household name, a strategic partner of ours that provides a lot of HVAC systems and productions. And Tim Johnson is the head of Alliances and Digital Ecosystems. Tim unfortunately couldn't be here, but he's been kind enough to share a video. So we'll just go ahead and listen to this video for the next couple of minutes.
Hello, and thank you for having me. I'm really excited to be here with you all virtually, albeit virtually. And thank you to AWS team for having me here to talk a little bit about Carrier and how we launched Abound, which is our smart and healthy building platform. It's a SaaS delivery solution, and how we work with AWS to deliver that capability to market. So a little bit more on Carrier. Carrier went public back in last April in the middle of COVID. We had been a part of a conglomerate called UTC, or United Technologies, for a number of years. And with this ability of going public, this really launched Carrier as its own entity and really gave us the ability to self-direct and think about how we want to deliver new capabilities and really go through our own digital transformation, both internally as well as externally, to deliver new products and capabilities to market. And so with that, being a manufacturer, we think about IoT and the future. And really the future from our perspective is every device will need to be connected. It will need to be smart to some degree. And it's going to have, IoT type data associated with it. So, our goal and our strategy is to deliver best in class products and services that really work seamlessly together and deliver new kind of digital capabilities and products to market to drive new solutions and opportunity for our customers. So our approach to IoT is very similar, obviously, from what you've been hearing from the IoT team today with AWS. We've really leveraged the edge. So, if you're making the edge, whether that edge device is a chiller, an air conditioner, or even a whole building in a bounds case. So how do you connect to these things on the edge and move that data, this IoT data, up into the cloud where it's normalized, and then have access to the data where you can visualize what's happening. So from our perspective, having a common platform, common look and feel. So from our customers' perspective, being able to understand and get information from products and services and capabilities, and really leverage that to better drive and operate not only their devices, but at the end of the day, their business. Carrier's been around for over 100 years. We were the inventors of the modern air conditioner, and really have been a technology company for all these years, and very much delivering quality products. So that continues. So our legacy as the inventors of the modern air conditioner, we're really forward thinking about digital capabilities and IoT and how we can continue to innovate into the future. So just some examples of that. We made an announcement last year with AWS about how we're working together to deliver new capabilities for the cold chain. Also too, last year in COVID, we won a Times Best Invention Award for the OptiClean unit, which is an air purification system that we got to market very quickly, obviously to help address some of the challenges that we're seeing in times of COVID, and as a result, being able to get a product very quickly to market, being recognized for innovation an opportunity to take new capabilities and technologies to market. Some of the challenges that we see, I mean, we've been in the building space for a long time through our various technologies, but there are some challenges in the modern building environment, or the built environment, as many people talk about. And obviously with COVID, that's brought to light, you know, safety and productivity. There are challenges there, and even before COVID, there were challenges in how do you understand what's happening in that environment from a health and safety perspective that affects productivity, and how do you make, especially in today's world, how do you make people comfortable in that environment so they can return back to the office, back to school, or back to the stadium. So we're really focusing this solution and capability around addressing these challenges, really delivering a smarter and healthier building. What's interesting though, that these health things actually come with real ROI benefit. So whether that's, you know, improved productivity, improved personal health, and also just kind of at a global scale, like improving societal health and capabilities, and really helping people, owners and operators and building managers understand what's happening in their facility and how that can be leveraged to actually deliver better outcomes, not just for the building performance, but actually for the occupants. And why buildings were built was to house us as we're doing our work, or as we're going to school, or going about our normally day-to-day business. But the reality is, we spend a lot of time indoors. So how do we start to get IoT data, information, bring that together to actually drive better outcomes? So with that, I'd like to introduce Abound. As I mentioned, Abound was launched in April of this year, and really re-envisioned as a digital platform. So Abound is really a cloud-native platform that gathers performance data from various systems within a building, whether that's the BMS system. Additionally, we could add additional sensor capability to really understand operationally what's happening within that building, and also understand things like indoor air quality, and adding additional sensing capabilities on top of that, whether that's indoor air quality sensors or things like occupancy sensors, to actually get a better picture of the spaces and how those spaces are being used and optimized, not just for building performance, but also for occupant safety and health. So if we really think about the different personas from a building perspective, obviously you have the building owner's viewpoint. So from a building owner perspective, they might have a portfolio of buildings, and looking across their portfolio of assets and really being able to understand what's happening with those assets and track and benchmark performance across their whole portfolio of buildings, and looking at at a holistic level through a single pane of glass, and then to be able to also drill down to a individual building, to an individual floor, or even individual asset or sensor within that building. Another persona that we've identified and are positioning information to is a building operator or facility manager. They're typically focused on a particular building. They want to understand what's happening within those four walls, and helping them prioritize tasks, understand challenges in real-time perspectives, in particular like the health of that building, whether that's at a floor level, a building level, or even like a room or conference room level. So being able to see this in real time, see information in real time, and proactively address and resolve challenges that might pop up during the day-to-day operations of that facility. And really the third piece that really brings it all together is the occupant. So being able to share information with occupants, whether you're the facility manager or the building owner, helping them understand the investment that's happened in the building. Typically you have building automation systems, you have equipment, you have HVAC systems. So how do you help them understand that you have an investment, that you're looking at your building, you're thinking about operating it, not just efficiency, but also how that can be translated into healthy spaces for our occupants, our employees, and so on. In terms of use cases, Kira is actually using Abound in its own buildings. This is a snapshot of our headquarters down in Florida. It's called the Center for Intelligent Buildings. We brought together, various technologies, but are using Abound to really help showcase how technology can be used within our own four walls as well, and leveraging that for our own purposes and our own use cases. So helping customers understand that we can bring them down to the CIB, the Center for Intelligent Building, and showcase some of these types of technologies and capabilities that we can deliver together. Okay, a little bit more on AWS and how we're able to build on AWS. So, architecturally, we touched on it briefly, but really you can think about the ability to add new sensors, so overlay new sensors, whether that's indoor air quality sensors, occupancy sensors, IoT type devices, bringing that straight up into the cloud, also leveraging edge gateways in order to connect to existing assets on the ground, so whether that's an HVAC system or an entire building, being able to bring that data through a normalization layer and leveraging the cloud to really scale that out in a great fashion. And so this is all visualized through Abound. Abound is the user interface capability that brings all these things together under one pane of glass. So from a AWS platform perspective, we were able to get to market very quickly with this solution, leveraging a number of key services and core capabilities within AWS, including Kinesis, IoT Core, Firehose, Event Bridge, and Redshift. So having those native services available to actually construct and deliver Abound in a very solutionized fashion was very optimal for us to really get to a SaaS-based delivery model and get to market very quickly. So some of the benefits, one was speed. We were able to envision Abound, do basic research on Abound, and then get to market very quickly. So in less than a year's time, we were able to envision a product, build a product, and deliver that to market. Additionally, obviously, with a cloud-based platform, it gives us scale. Carrier being a global company, we think about how do we deliver the solution globally across the world and servicing all different types of customers. So whether you're an office environment, a school, or a sports arena, how do we scale across these different capabilities? And then really a platform to innovate. So we're excited by the innovation, the capabilities that we're able to bring to market very quickly. And we expect to continue to do that in a very agile fashion, leveraging AWS's technologies today and also for tomorrow. So what's next? For us, we're going to continue to innovate. We've got a great base platform in Abound. We have an agile methodology that we're going to continue to innovate and add new functions and capabilities with Abound. And that includes, in particular, providing action and intelligence. So being able to have smarter buildings and have the ability to operate more autonomously. Thinking about ESG capabilities. So, one of the requirements we see in the future is really helping translate energy efficiencies and operational efficiencies, and how do you translate that into ESG requirements, and helping companies understand that envelope and how their buildings and facilities can help provide or reduce carbon and help drive their ESG goals in the future. So with that, again, we're super excited to partner with AWS. We see a tremendous opportunity to surface data and create new insights. In this case, talking about Abound and how we can deliver new outcomes for our customers in the building spaces and actually deliver new insights. So really excited by the future and the opportunity to work together with AWS. And again, I really appreciate the time and opportunity to speak with you all. And thank you again, and enjoy your time.
Right. Thanks, Tim. Okay, so Tim, talked to us a bit about data-driven communities, right? And we're going to switch gears into data-driven industries or manufacturing processes. So let's go through this here and really highlight how there are similarities in these solutions, but we'll focus more on Industry 4.0 and this digital transformation within manufacturing. And so personally, I've worked in the industry for over 15 years in industrial automation, and it was Industry 3.0. There was a point when we focused really on the problems at hand, at the process we were monitoring, and we were reactive to it, right? If there was alarm events, we would service those and maintenance. But really, Industry 4.0 takes you to this new revolution. We call this the fourth revolution of industrial customers. And this is where you start to bring in technologies like the Internet of Things, so the industry of Internet of Things. And this digital transformation, really the goal for our customers, the outcome, is to give you, really access to this data from asset-intensive types of industries, which would involve manufacturing, this would involve energy, oil and gas, renewables, mining, agriculture, right? You see the various types of industries we see here. And what the goal is to help our customers adjust various levers to optimize their performance in their operations, ultimately helping grow revenue, lowering costs, and providing those type of value and services for their customers. And so the journey for our customers in this industry, for data-driven industry operations, the customers again are moving away from being reactive or planned maintenance situations. And that was typically before the case, right? I would schedule maintenance routinely to service a machine that was performing okay. But this way I can ensure that it had optimal uptime. And with data-driven methods, we try to achieve being predictive and prescriptive. Being able to analyze these data sets, marry that up with our manufacturing execution systems or our enterprise resource planning system or ERP systems, and really try to derive some insights that can help us predict and build models to prescribe to our operators and our plant managers how they should service and keep optimal uptime of their assets. And so there are 3 stages of what we call predictive maintenance, and it starts usually with anomaly detection. So using things like algorithms like random cut forest, you can detect anomalies in your data sets, in your time series data. This can also lead you to ways to help you diagnose or do identity of root cause analysis through your data sets. And so being able to have access to time series data, operational or production data, and look to find where problems are based on certain downtime events. We give that ability to our customers within what we call Industry 4.0. And the end goal here is to then provide that prediction or prescription on how you should maintain or service your different processes and assets. So customers I've worked with, like Lockheed Martin, right? They use our services today, like IoT Core and Greengrass, and they wanted to take that next leap in modern manufacturing in Industry 4.0. So being able to marry the technologies you see in operations and IT. And with this, they're able to ingest data securely by pulling information from CNC machines or that type of equipment, using their protocols in that industry with Greengrass, and then transmitting this telemetry data and production data to the cloud in their GovCloud account. Right? So we have these services in place that are Impact Level 5, FedRAMP High, and support these types of processes you need in your organization. And with this, they're streaming data to Kinesis data streams into their data lake, where they're now doing analytics on this data sets. And this is hopefully will help them eliminate paper waste, optimize labor, and unlock insights in their operation. Some partners like we have here, like AdLink, they built a smart pallet management system. And this essentially efficiently analyzes at the edge with machine learning models to detect what they see for barcodes on pallets that are passing through. And with this information, they can cross-reference against inventory systems, warehouse management systems, or ERP. And they have deployed this for customers, like for example here, a US meat producer, where it has improved inventory accuracy and operator productivity. And it was significant improvement. They see an ROI here of over 1,000% over 3 years. So being able to deploy this type of technology to the edge can really help automate a lot of processes that were before manual tasks and prone to error, and significantly improve your production. So at AWS, we really have a focus on industrial as well, and we provide a set of services to help customers in that space. So IoT Sitewise is a service that we provide. It lets you have several capabilities in a managed service. You don't worry about storage or infrastructure. This will manage that for you and scale as you grow. But it allows you to have collection, so a time series database built in, storage of this data, so you can do analytics, calculate metrics on your data, organize it in an asset hierarchy, and also give you visualization capabilities. And so that service is something that you can deploy those capabilities to the edge with Sitewise Edge, and also have it execute in the cloud. So a very powerful set of services and features. We also give you other capabilities with machine learning, like with Panorama. So this is an actual physical appliance you deploy to your facilities on-prem, and it will support connecting to existing CCTV cameras that you may already have, and then apply machine learning models to those. So making those cameras smart, right? So you can imagine you can do a variety of things. Maybe look to see if there's hard hats on people's heads for safety reasons. It could be just looking at the location of assets that may exist within a shop floor or shipyard, right? I need to locate where my welding machines are or my forklifts are. So a lot of capabilities you can do with Panorama. There's also other services for lookout for equipment, where we analyze time series data to detect any anomalous behavior in machines. And if it's for machine learning with vision, where you want to do essentially anomalies in your production of components, you can look for defects and train that service with vision to actually look for defective products. And with the training process that we guide you through, it makes it very easy for you to actually create this type of detection service. And that leaves me also with Amazon Monotron, probably the coolest name we have at Amazon. But with Monotron, these are actual physical devices you use typically for condition-based monitoring. You stick them on various types of assets. You may detect vibrations, and then be able to detect when there's potentially a failure that might happen. And so with Monotron, these are wireless sensors you place in through a gateway and ingest this data into your account. Thanks.
All right, so hopefully that got you thinking of some project, right? So all the services we saw, the examples, hopefully everyone's thinking of, hey, here's an opportunity, here's a project I've been working on, maybe we can apply some of these services, maybe we can make something happen. So how do we go about it? For us, partners are a big focus area, a big go-to-market. So we focus heavily on partners, like I mentioned, on the consulting side, but also on the technology side. So if you have a project that is of interest, we could probably connect you with a partner that already provides a solution, or a partner that can help you build that solution. Right? And I mentioned a lot of different use cases around lighting, parking, waste management. So we have ISVs that typically focus on each of these solutions and provide off-the-shelf products that can be tweaked as well. But AWS itself is also in a position to help our customers. Right? The first thing is, if you want to learn more about these IoT services, and if your team wants to start playing with some of these services, start to build something, we have a series of workshops, IoT Workshop that we provide, and hopefully you'll get these links later on. But you can actually go in and do some self-paced workshops. Some are focused on the industrial environment that Chris talked about. Some are just focused generically on IoT. So these are like 3-4 hour self-guided workshops that anyone can start taking and learning about these services, playing with these services themselves. The second thing we actually launched yesterday is a rapid adoption initiative. This is focused on IoT, also AI and ML. So again, if you have a project, if you have this idea on IoT and you want to utilize AWS services and want some help, you can come to this link, you can submit a form, and what that does is generates an intake, and we can apply our technical resources to come sit down with you. And what we do is we deliver 3 sort of workshops. One is, forgetting the terms, a discovery workshop, right? To understand what is the project, what is the outcome you're desiring, and how far have you gotten along so far, and how do we help you get there. The third was an enablement workshop to help you get enabled with our services so you can start building some of this for yourself. That's the second one. And the third one is an actual build workshop where we sit down with you to say, all right, we figured out the discovery, we figured out what we want to build, let's just do it. Right? Let's just get your developers, our SAs together and actually build a demo. build a prototype, get something going, something working that we can now show off and be like, hey, look, this works, and here's the ROI generated from it. Right? So AWS is builders. We would love to get involved with your project and help you build stuff and turn it into reality. So with that, I'll wrap up this session. Oh, there you go. Just want to thank your time today. I know it's early in the morning, but I appreciate everyone coming, paying attention, and hopefully you've learned a couple of things. And the last piece is do not forget to fill out the survey. Really appreciate that. Thank you.